Hello everyone and welcome to the Reactive Angular course. I'm Vasco from the Angular University and I will be your instructor for this course. This course is a catalog of commonly used design patterns that every Angular developer should know. The goal of the course is to teach you how to comfortably design and develop Angular applications in reactive style using plain RxJs and nothing more. In this course, you will learn exactly how to use RxJs to design and develop both the service and the view layer of your application. You will understand in detail both the benefits and the pitfalls of adopting a reactive approach. Our general approach is going to be to teach you how to build Angular applications mostly in a stateless way, while adding some specific state management in the parts of our application that need it. Specifically, when it comes to state management, we can go very far just by using plain RxJS techniques without the need of introducing a third-party library for managing our application state, such as, for example, NGRX. These simplified state management techniques using plain RxJS are adequate and sufficient for a very large range of Angular applications, especially enterprise applications. And you should consider these techniques that we are about to teach you in this course before adopting a full-blown state management solution. So here is how we are going to structure this course. We are going to start by taking an existing Angular application written in plain imperative style, and we're going to refactor it into reactive style so that we understand the benefits of the reactive approach. Initially, we are going to keep the application completely stateless, but as the application development progresses, we are going to start to need some state management on the client side, both for implementing certain critical features such as managing the user authentication profile, which is something that almost every application has to do, but we will also want to add state management in order to improve a bit the user experience and avoid showing so many loading indicators to the user and avoid calling the backend so many times as we navigate through the multiple pages of the application. As we refactor our application into reactive style, first in a completely stateless way, we are going to learn how to build our service layer in reactive style, and we're going to learn the difference between smart and presentational components. We are going to learn how to build our service layer using a common design pattern known as the stateless observable service, and we're going to learn the importance of the RxJS share replay operator in building services in Angular using the Angular HTTP client. Every time throughout the course that we come across a new RxJS operator, we're going to take a moment to explain it in detail. So this was the first part of our course where we mostly talked about Angular service and view layer design and Angular stateless reactive techniques. Through the rest of the course, which is going to constitute the bulk of the course, we're going to talk about lightweight Angular state management techniques using plain RxJS, and the key ingredient for this set of design patterns is going to be the RxJS behavior subject. So we're going to make sure to take the time to explain how it works in detail. We are going to show how to build a behavior subject store in order to manage the user authentication profile, which is information that we want to load in our frontend only once and make it available to multiple pages of our application. Let's remember that depending on the information available on the user profile, we might want to show or hide certain parts of our application to the user, depending on the fact that the user is logged in or not, or depending on the fact if the user is an administrator, for example. We will also show how this type of service stores can be used to improve a lot the user experience in certain parts of the application. We're going to learn how to build a service store that stores business data, not just technical information such as, for example, the user profile. We will also learn how to use the behavior subject as a mechanism for inter-component communication. So we will see how this type of services can be used to have components at very different levels of the application tree to interact with each other in a decoupled way. We are going to give a couple of examples of this type of reactive decoupled communication between components by implementing some common use cases. We are going to show how to do error handling in our application by having different parts of our application display an error message to the user in a top messages panel just below our menu bar in a decoupled way. We are going to see how to implement a commonly used feature in any Angular application, which is going to be a loading indicator, which will be controlled by a service with a reactive API. We will also talk about other commonly used reactive design patterns, namely the master detail with cached master table. We are going to implement it step by step in a reactive way. At the very end of the course, after a consolidation exercise, we are going to talk about an important reactive design pattern for Angular applications, which is known as the single data observable pattern. That is going to help us to avoid a common Angular anti-pattern in our view layer, which is to nest multiple ng container tags inside each other just to access our reactive data. At the very end of the course, we're going to show how easy it is to convert an application written in reactive style in order to use Angular on-push change detection if necessary, which is an optimized Angular change detection mode that does not tend to work very well with applications written in imperative style, but works particularly well for Angular applications written in reactive style. In summary, with this course you are going to learn everything that you need to know in practice in order to design and build Angular applications in reactive style. You are going to learn how to keep your application mostly stateless. You are going to learn how to design and develop both the service layer and the view layer in a reactive way, and you are going to learn how to use lightweight state management techniques at specific parts of your application in order to improve the user experience and implement certain key use cases that absolutely need state management. So I hope that you will enjoy the course. I want to thank you for watching. If you have any issues or questions, comments about the course, please let me know in the comment section below. And without further ado, let's get started learning Reactive Angular together. Hello everyone, and welcome to the Reactive Angular course from the Angular University. In this lesson, we are going to set up your development environment. You will need a proper development environment in order to code along as we go. That is the best way to take this course. However, this is optional. You can also simply watch the videos and learn that way as well. The course is designed to be useful if you take it in either way. This course comes with a running GitHub repository. So the first thing that we're going to do is to head over to the Angular University GitHub page. From here, we're going to scroll down, and here in the Find a Repository text box, we are going to type the name of the repository, Reactive-Angular course. You should see here this repository, Reactive Angular course, how to build Angular applications in reactive style using plain RxJs. So this is the correct repository. If you can still see this repository in your search, please don't use it. This is the old version of the course. So again, the correct repository that we are looking for is called Reactive Angular course. Let's click into it and let's scroll down in order to confirm that we are indeed in the right course. So this is the correct course with this thumbnail that we can see on the screen. The master branch of this code repository that we see here contains the final version of the course code. So if you are coding along throughout the course and you find some difficulties, you can always check back here in the master branch of our repository and see what the final solution for that section looks like. However, in order to start the course, we are not going to be using the master branch. Instead, we are going to click here on the branch dropdown, and you are going to see here multiple options available. We are going to be choosing the one-start branch. So this branch contains the code that we will need right now at the beginning of the course. You can obtain the correct version of the code in two ways by using here the clone or download button. So if you choose download zip, you are going to get a zip file containing the 1-start branch or the master branch, depending on the branch that you have selected here on the branch dropdown. However, if you prefer to use Git, you can also clone the repository and switch to the 1-start branch. We are going to show you the commands that you need to do that further on in this lesson. In one of these two ways, you are going to get the lessons code and you are going to have it installed in your machine. In order to be able to use the code, you're going to need a couple of things in your development environment. So the first thing that you need to install is a version of Node.js. You can head over to nodejs.org and get the long-term support version of Node, which is the LTS version. I recommend that you use the LTS version and not the current version, as the long-term support version tends to be a bit more stable. Now you can also optionally install Git in your development environment. This is going to allow you to easily switch branches in your repository, and each branch is going to correspond to different sections of the course. Besides having Node in your machine, you are also going to need an integrated development environment or IDE. This course is going to be done using the WebStorm IDE, which is an excellent JavaScript and TypeScript IDE. You can download here a free trial, but if you prefer a completely free IDE, you can also use Visual Studio Code from Microsoft, which is also an excellent IDE. Once you have everything installed in your machine, meaning Node, optionally Git, and also one of the two TypeScript IDEs, we are now going to install the lessons code. So let's remember that the branch that we need is the 1-start branch from the Reactive Angular course. Again, you can get this branch by cloning it as a zip file or simply by cloning the repository and switching to that branch. Either way, you're going to have the lessons code installed in your machine, and we are now going to switch to the WebStorm IDE in order to finish the installation process. So we are here under the Reactive Angular course folder, which is the root folder of our repository. Now, in this case, I did not download the code as a zip file. I instead cloned it using Git. So now if I type git branch, we can see that we are on the master branch. So if you want to switch to the start branch, which is the correct branch that we need at this point in this course, we're going to run the following command, git checkout 1-start. This is going to switch automatically to the 1-start branch. From here, and making sure that you have the Node long-term support version installed on your machine, we're going to run the following command from the Reactive Angular course folder, npm install. This is going to take a moment, but after a while, all the necessary dependencies are going to be installed under the Node modules folder. After a while, the installation is going to be completed and we are now ready to use the lessons code. The first thing that we're going to do is to open here a second terminal where we're going to run the command npm run server. This is going to start a small Node HTTP server that will be available here on port 9000. This contains a very simple server that we can use to retrieve some data from our Angular frontend. We can also modify some data in memory in our server. The server does not contain a real database. The data exists in memory on the server. It's just a simple server for demonstration purposes. You can confirm that the server is correctly running by opening here a new browser tab, and we're going to access port 9000, and let's access, for example, the /API/courses REST endpoint. So if we access it, we are going to see that indeed we are retrieving here a JSON payload containing what looks like a list of courses. This is the data that our application is going to be displaying on the screen to the user. The next thing that we need to do is to start our front end that is going to connect to this backend automatically. So we're going to run here the command npm start. And it's important that we use this command npm start and not the Angular CLI command ngserve. npm start is also going to be using ngserve, but it will also pass it some extra parameters, as we will see. So as we can see, npm start uses ngserve to start our server, but it also passes to the Angular CLI a special proxy configuration. We are going to understand later on in the course what this configuration is for. Meanwhile, after a couple of minutes, the server startup is going to be completed and we can now access our frontend. We can do so by accessing localhost 4200. This is going to take a moment, but after a while you are going to see here a small Angular frontend running. So this is the starting point of our Reactive Angular course. This is a small sample application that is currently written in imperative style. We are going to refactor this application into reactive style and talk about the differences between the two approaches. We are also going to improve the user experience by applying some lightweight state management techniques. Hello everyone and welcome back. In this new lesson, we are going to start the refactoring of our home component into reactive style, and we are going to discuss the benefits of that new approach. First, let's talk about some of the problems with the current version of the program. As we can see, we are manually here calling subscribe, and we are adding here some logic in the body of our success handler. So this is the callback that gets called whenever this HTTP observable successfully emits a value. Now, this type of code can easily degenerate in a more complicated example into callback hell. Let's have a look at a typical example of code that suffers from callback hell. So you might have encountered it before if you have maintained programs that don't use, for example, promises. These might be the typical type of logic that you have encountered before. So we are using here a function that has asynchronous behavior. So it doesn't immediately return a result. The result is going to get returned to us asynchronously by a callback function that we have to provide as the last argument of the function. So here is the input data of the function, and here is the callback that we want the function to call whenever the result is available. The callback usually follows this convention here. The first argument is the error and the second argument is the output of the function. We start by checking for multiple types of errors, and if no error occurred, then we might do here a call to a second function that also needs a callback. So as we can see, after several callbacks and after adding several times this type of error handling logic, we end up with this type of very nested code that is hard to read and reason about. It's very easy to end up with multiple levels of indentation, and it's also hard to read, understand, and maintain this type of program. This type of callback hell is something that we want to avoid by using observables. But going back here to our program, if we start to manually subscribe to the multiple observables that we have available, we are going to very quickly end up with the same problem. So this is not the right way to use observables. Another potential problem with this component is that there is too much logic in this component. The component knows a lot about where the data comes from. The component knows that the data comes from the backend. The component also knows how to do the HTTP call and how to process the data that it receives. Ideally, the component shouldn't be aware of where the data is coming from, and also it should be easy to test this component in isolation without having to use a real HTTP backend. Also, we might want to do this call elsewhere on the program. Somewhere else on the program, we might also need the same data. So this logic here, because it's embedded here inside the ng-oninit method of the home component, is not reusable elsewhere in our application. Also, our home component has these mutable beginner courses and advanced courses variables. Keeping data in these local mutable state variables is potentially problematic. If we make a change to this data here locally in the component, there is no way for the rest of the application to know that this data was modified. Modifying the data directly at the level of a component by mutating a member variable might introduce subtle dependencies with other components of the application, making our program harder to reason about. Also, if we would like to use an optimized change detection mode known as onPush, we would not be able to do so in a program where member variables are being mutated at the level of a component. This is because on onPush change detection, each component determines if the template should be re-rendered by looking at its inputs. If the data is being directly modified at the level of another component in the application, then there is no way for a component using onPush change detection to know that the data was modified. Ideally, what we would like to achieve here is a solution where the component does not know where the data comes from, it simply receives it when a new version of that data is available. The component should be able to display the data without necessarily keeping these local mutable variables that open the door for potential bugs. Also, the program should be written in a way where there is no nested code like the one that we have here. Ideally, our code should be flat, a bit like if we would write our program using promises. Let's see how refactoring this component into reactive style is going to allow us to solve all these problems. Hello everyone and welcome back. In this lesson we're going to start the refactoring of this component into reactive style, and we are going to start by creating a proper service layer for our application. The service that we are about to write is going to be a stateless observable service, which is the first design pattern that we are going to cover in this course. To get this refactoring started, let's go back to the analysis of the current version of the home component. So as we can see, the component here is receiving the Angular HTTP client, and the component also knows how to use the HTTP client in order to get data from the HTTP backend. The component knows what endpoint to call, and it also knows how to process the HTTP response. Now, ideally, we would like to place this logic in an Angular service where it can be reused by other components of the application that also want to call the backend. So let's start with that. We are going to create here under our app folder a new folder that we're going to call services. Inside this services folder, we're going to create a new file that we're going to call courses.service.ts. Inside it, we are going to be defining a new class that we're going to call courses service. Now we are going to make this an Angular injectable, and we are going to make it a root injectable of our application. This means that there will be only one instance of this service that is available to the whole application. The courses service is going to be using the Angular HTTP client in order to access the backend. So let's go ahead and inject the HTTP client here in our constructor. Now going back here to our home component, this is the logic that we would like to isolate in our courses service. Let's start then by removing here the HTTP client that will no longer be accessed by the home component. Instead, the home component will only know about the courses service. Now let's see how the home component is going to retrieve the courses data from this service. We are going to be defining here in the public API of our courses service a new method that we are going to call load all courses. And it's important now to discuss what type of API should this method provide. You might be tempted to try to build a method that simply returns here an array of courses, or alternatively that returns a promise of a course array. Now, that's not what we are going to be doing in this course. Instead, we are going to make this a reactive service. This service is only going to be returning observables. We are going to be returning here an observable of course array. So this observable that we are returning to the view layer is going to emit values over time. And actually it will only emit one value if the HTTP call to our backend is successful. That value will be the array of courses. The home component, on the other hand, is going to receive the data from the courses service without knowing necessarily where the data comes from. It might come directly from the backend, it might come from an in-memory cache, from another service or component that is transparent to the home component. Let's then quickly implement this logic. we are going to be returning here a new observable that we are going to be deriving from our HTTP GET observable. Let's then access the Angular HTTP client. Let's do a GET call. We're going to be hitting the /API/courses REST endpoint as before, and this is already an observable. Notice that we still get here a compilation error. This is because the expected type is not the one that we have defined here. So this does not automatically return an observable of course array. Instead, we need to pass here to the get call a parametric type, which defines the type returned by the HTTP GET observable. In this case, we know that the values emitted by this observable are going to be of type course array, and this fixes the problem. Now, even though the compilation error has been fixed, what we are actually returning here is not yet a course array. Here we are returning the HTTP response without modifying it, so if we would run our program, we would see that this observable is emitting a value that looks like this, a JavaScript object with a payload property containing an array. So that's not what we want to return here. Instead, we want that the values of this observable are directly the course array and not an object containing a payload property. So what we're going to do here is we are going to transform this observable into another observable that emits the values that we need by using the RxJs map operator. So RxJs operators are chainable functions that allows us to quickly combine different observables in order to obtain different types of results. In our case, we simply want to create an observable that is derived from the one that we already have here. So we're going to be using the map operator, which is one of the most essential RxJS operators. Let's have a look at a diagram that explains how the map operator works. This is from the official RxJS documentation, and this is known as a marble diagram due to the colored circles here on this type of diagrams that resemble marbles. Now here on top we have the example of one observable. This observable simply emits the values 1, 2, 3 and then it completes. Now how does the map operator work? The map operator is going to take as an input a mapping function. For example, this function here takes as an input a value and multiplies it by 10. What the map operator will do is, taking the original source observable 1, 2, 3, map is going to create a derived observable. This observable here at the bottom. Now the values of this derived observable correspond each one to the values of the input observable multiplied by 10. So as you can see, 1 times 10 becomes 10, 2 times 10 becomes 20, and 3 times 10 becomes 30. Let's then now take what we have learned from the map operator and let's apply it here to our program. So we have here an observable that is emitting as values this object, and we want to map it to an observable that is emitting only the course array. So the value that we receive here is going to be the full HTTP response as we see here on the screen, an object with a payload property. Now the output of this mapping function should return us only the course array. So we can return that by accessing here the payload property of the response. And with this, we have used the map operator in order to implement the load all courses method. Now we are going to return to the courses service multiple times throughout the course. What is important to retain right now is the type of API that we are building here. So our service layer does not return mutable data values, such as, for example, a course array directly. Our service layer does not return promises. Our service layer, by design, will only return observables to the view layer. Also, and very importantly, the data emitted by the returned observables is not kept here in our service. So our service is stateless, meaning that it does not hold any application data. The only thing that this service holds in memory is a reference to the HTTP client in order to be able to do the HTTP calls. Other than that, the data returned is only accessible by the home component and anywhere else in the application by subscribing to the returned observables. The courses service itself does not have access to the application data and does not keep it in memory. It's a stateless observable based service. Let's now see what is the best way for the home component to consume data emitted by this service. Hello everyone and welcome back. In the last lesson we have created the first version of the courses service, which is a stateless observable service. Let's now see how this type of service can be used by our view layer, in this case the home component, which corresponds to this component here on the screen. Now we have already injected here in our constructor the courses service. Let's now remove this code that is no longer compiling from ng on init, and let's see how can we provide the data that the view needs from this courses service instead of calling the backend directly from the home component. So the first thing that we are going to do is on our ng on init method, we are going to call the courses service load all courses method. As we know, this is going to get us back an observable. So let's create here a new variable called courses, and in order to make it easier for us to identify the variables that are observables and distinguish them from the variables such as, for example, these two here, which are not observables, we're going to be adding as a convention a dollar to the end of any variable that represents an observable. So we have here the courses observable, and we can confirm the type of this variable by using Ctrl+Shift+P and checking that this is indeed an observable that emits as values course arrays, so lists of courses. Now that we have the courses observable here, we need to find a way to pass the data emitted by this observable onto the view. Before, we were passing data to the view using these mutable state variables here. In a component written in reactive style, these mutable state variables will no longer be present. Instead, the component only passes data to the view via observables. So we will have here two observables, a beginner's course observable and an advanced courses observable. So this is what a typical reactive style component looks like. All the data variables are observables. Now we are going to see, before defining these observables and deriving them from the courses observable, we are going to see how these observables are going to get consumed by the view. Switching back here to our template, we could see that here we were passing the beginner courses and scrolling down the advanced courses mutable state variable to our template. Now these variables no longer exist. What we have are observables that emit the values that we want. If we try to pass the observable here directly, this will not work. Instead, what we want to do is to find a way for the view to subscribe to the observable and to get the values emitted by the beginner courses observable. So we can do that here directly from the template by using the built-in Angular async pipe. This pipe is an absolutely essential construct in order to be able to build components in reactive style. Without this pipe, we would not be able to do proper reactive programming in Angular. The Angular async pipe is going to subscribe to the beginner courses observable and is going to make the values emitted by the observable available here to our template. So what we will have here in place of the highlighted expression is going to be a list of beginner courses, which are the values emitted by this observable. We can then iterate through the list of courses by using the normal ng-for syntax. In a very similar way, we are going to be using the async pipe in order to access the advanced courses. Let's take the advanced courses observable and let's then apply it the async pipe. At this point, we now know how an Angular view layer and more concretely the Angular template, can consume observables from any component. As we can see, the key ingredient in order to make everything work is really the async pipe. The async pipe will not only subscribe to the observable and get its values available to the template, but also when the component gets destroyed, this async pipe will also unsubscribe from the observable if it's not yet completed or errored out, and this way we will avoid any potential memory leaks in our component. This also means that in our home component we will never have to take care of unsubscribing from these observables manually. And actually, in the case of observables that contain data that we want to pass to the component, we will typically not have to subscribe manually to them in our component at all. Ideally, this type of observables that contain the application data should only be subscribed to by the async pipe from the template directly. Now, these variables are not yet filled in. Let's see how can we derive the beginner courses from the courses observable. So like we did before, what we want to apply here is the RxJs map operator in order to derive beginner courses from a full course list. Let's access here the courses observable and let's apply here the RxJs pipe syntax. So this will allow us to chain multiple operators together if needed. In our case, what we want to do here is to apply the RxJs map operator, and we want to take here a list of courses and we want to filter the list by course category. We want to search only for the beginner courses. So what we need is to access here the courses array, and here we're going to be using the array filter function. So this is not an RxJS operator, we are simply doing here a plain JavaScript array filter. So the elements of this array are courses, and we want to return here the value true if the course category corresponds to beginner. And with this, we have defined here the beginner courses observable. We are now going to be defining the advanced courses observable, which is going to be very similar. So for the moment, I'm going to take the definition of beginner courses and I'm going to duplicate it. I'm going to now define here the advanced courses. So the only difference is that here the category that we want to filter on is going to be the advanced category. Both of these arrays, the array containing the beginner courses and the array containing the advanced courses, now need to be sorted based on the sequential number property. So each course has a sequential number property and we want to sort these lists using this property. So for that, we're going to be applying the sort courses by sequential number function that is already here, ready to be used. Let's switch back here to our home component and let's apply the sorting only in one place here at the level of the courses observable. Let's apply here the RxJS pipe syntax, and just like we did before, we want to be able to map the courses that we have here and produce a new array that is now sorted. So let's take here the courses array, let's call the array sort function, and let's pass it the sort courses by sequence number function. And with this, we have finished implementing the reactive version of our home component. As we can see, we no longer have here mutable state variables. Instead, all the data variables are observables. These are subscribed to by the home component using the async pipe. This means that the view does not know where the data is coming from. The data is being pushed to the view via the observable. This is a very different situation than what we had before. So before, the component was using the HTTP service in order to pull the data into the view. The component knew exactly where the data was coming from. In this case, this component only knows about the courses service, but it does not know anything about how the courses service is implemented. We are calling here load all courses, and we are getting back an observable that we use in order to push the data into the view when the data is available. But we are not triggering ourselves the HTTP request. Now, in the case of our courses service, what we are doing here is we are using the HTTP client in order to do a call to our backend. But the home component does not know about that. This is an internal implementation detail of our stateless observable service. We are returning here an observable of course array, and this observable is going to get passed into the view. The values are going to be made available to the view via the async pipe, which is going to subscribe to this observable. Let's then summarize some of the advantages of the refactoring that we have just made when compared to the initial version. The first advantage is that we have here this new separate service that we can reuse elsewhere in our application. So if somewhere else we need to load the courses from the backend, we can do so by reusing the courses service. Besides making the service logic reusable, another advantage of our refactoring is that now we no longer have here potential callback hell in our home component. So everything is being defined via observables. If we want to modify our data, combine it together, we can do so by combining the multiple RxJs operators that are available. That will ensure that our code remains flat and without deep levels of nesting. Another big advantage of our refactoring is that now the data, the beginner courses array and the advanced courses array, is no longer available here via mutable state variables. Instead, we only have here these observables, and with these observables we cannot access the data that they are emitting. The only thing that we can do is subscribe to the observables. Another advantage of this refactoring is that now we are subscribing to our observables using the async pipe. The async pipe will not only subscribe to the observables and make the data accessible to the view, but the async pipe will also take care of unsubscribing from the observables and therefore avoiding potential memory leaks that can happen whenever we are subscribing to our observables manually. If we look closer to the implementation of the home component, we are going to notice that nowhere did we need to do a manual observable subscription. We are now ready to try out this new version of the home component. Let's go ahead and refresh our user interface. As we can see, everything is still working as expected, it's the same functionality, but we now benefit from all the advantages of our reactive approach that were mentioned before in this lesson. Let's now continue the implementation of our courses service and of our home component. We are going to be introducing a couple of new reactive patterns and anti-patterns. Right now, our reactive solution is completely stateless, meaning that every time that we navigate away and back from this page, we need to reload the courses again. But later on in the course, we are going to learn how to use RxJs to do some lightweight state management as well. Hello everyone, and welcome back. In this lesson, before going any further with the refactoring of the home component, we are going to first talk about a common anti-pattern that we tend to find when we look at services such as, for example, the courses service, which is an Angular HTTP-based service, meaning that it uses internally the Angular HTTP library. Most of the times, the observables that we want to return here from this type of service should trigger the HTTP request only once. That is the expected behavior. For example, here, whenever we look at this program, we would expect that only one HTTP request to be issued to our backend, and the result would then be filtered out into two separate observables, one being the beginner's courses and the other being the advanced courses. However, if we take a closer look at our application at runtime, we are going to see that, surprisingly, that is not the case. Let's now switch to a larger window and see the runtime behavior of our application. I have here the Chrome DevTools opened and I have selected here the network tab. I have clicked here on the XHR filter so that we see only the AJAX requests made by our application. Let's now go ahead and refresh the application and keep a look here in our AJAX log. Now, besides the last request, which is a request made by the Angular development server and not by our application, we also have here, surprisingly, not one, but two HTTP requests that are hitting the /API/courses endpoint. If we inspect the content of this HTTP request, we are going to see that we get 2 times the same exact payload coming from the server. Now, this is really unexpected. We would expect that this request to be executed only once by our application. However, there are 2 requests here. Let's understand why this is happening and how to avoid it. Let's start by understanding why this is happening. So going back here to our home component, we can see that we are creating here a courses observable. This is built using the load all courses method from the courses service, which in turn uses the Angular HTTP client in order to produce an Angular HTTP observable that gets sent back here to the view. Now, these type of observables, HTTP observables, have a very specific behavior. They are going to emit only one value, and then when that value is emitted, the observable is going to then complete and no further values are going to get emitted. Now, if an error occurs while doing the HTTP request, then the HTTP observable is going to error out. Going back here to our home component, we can see that we take here the courses observable, and from it, using the map operator, we are going to derive 2 separate observables, the beginner courses observable and the advanced courses observable. That if we switch back here to our home component template, we're going to see that each of these 2 observables is being passed to the view using the Angular async pipe. So here we have the beginner courses observable being subscribed to by the async pipe, and here we have the advanced courses also being subscribed to using the Angular async pipe. So as you can see, we actually have 2 observables, each with its own subscription, and that is why we see 2 HTTP requests in our network log. For each subscription to the courses observable or to any other observable directly derived from it, we are going to get a separate HTTP request. Let's remember that in the case of observables, if we don't subscribe to this observable returned here by load all courses, then nothing will happen. The observable by itself will not trigger an HTTP request. This might be different for other types of observables, but in the particular case of Angular HTTP observables, everything happens in a lazy way, meaning that the request to the backend is only going to get triggered if somebody is interested in receiving the value emitted by the backend. So if somebody subscribes to the observable. If no subscriptions occur, nothing happens. So here in the home component, we then derive 2 observables from courses, we produce 2 subscriptions at the level of the view using the async pipe, and that results in 2 separate HTTP requests. Although this behavior of creating one HTTP request by subscription is the default behavior, this is almost never what we want in practice. What we usually want to do is to trigger the HTTP request only once, store the result of that request in memory, and provide the result of that request to any subscribers immediately without triggering a second HTTP request. Before showing how to fix this issue, let's now further prove that the cause of the multiple HTTP requests is indeed the large number of subscriptions. So 2 subscriptions here to 2 observables are giving 2 HTTP requests. So this means that if we would now subscribe here a third time to the courses observable, we should get 3 HTTP requests on the log. Let's simply subscribe then here to the courses observable, and let's log the value emitted to the console. With this third subscription in place, let's now switch here to a larger window. The application has already been reloaded by the Angular CLI, and we can now see here in the network log that we have indeed 3 HTTP requests. So the more subscriptions we do to the returned observable, the more HTTP requests are going to get sent to the backend. What we want to do in order to solve this problem is, instead of creating a new HTTP request per subscription, we want to create only one HTTP request for the first subscription. We want to keep the result of that HTTP request in memory, and we want to share that result with subsequent subscribers without triggering a new HTTP request. That behavior can be obtained with a particular RxJs operator, which is the share replay operator. Let's see it in action. Going back here to our program, We are now going to the load all courses method, and here in the resulting observable, instead of returning here directly the observable generated by map, we are going to further chain an operator here using the pipe syntax. So after applying here the map operator, we are going to also apply here the share replay operator. Let's now see this operator in action. We are going to switch here to a larger window. Let's refresh the application and let's keep an eye here on the network log. So as you can see, now we only have one HTTP request as expected. So going back here to our program, we can see that the multiple subscriptions that happen here at the level of the home component, including the manual subscription, but also the subscriptions made by the Angular async pipe, only result in the triggering of a single HTTP request. This is almost always what we want in practice. We don't want any of our HTTP requests, both data retrieval requests or data modification requests, to ever be issued twice accidentally due to multiple subscriptions. So in general, I would advise you for most of the times to add share replay to the HTTP observables returned by your Angular services. Notice that this is only applicable for this specific type of services. So Angular services that internally use the Angular HTTP client, which are probably the most common type of Angular services. Now that we know how to avoid accidental HTTP requests in our Angular application, let's switch back here to the home component and continue its refactoring. We are now going to be introducing a couple more of commonly used design patterns. Hello everyone and welcome back. In this lesson we're going to talk about a couple of useful design patterns. We're going to talk about smart and presentational components. In order to better understand these patterns, let's switch over here to the home component template. Now if we scroll down through the template, we're going to see that it's mainly made out of two lists of course cards. We have here the first list of cards, which is the beginner's courses list, and we have here another material tab panel containing a second list of cards. Now we are looping through the cards using ng4, and we are using here the mat card component in order to display a nice material card to the user. Notice that the code that defines the view of these cards is going to be identical for both the beginner and the advanced courses. So this code that we see here is almost identical to the code that we see here for the advanced courses. The only thing that changed is the input data that we see here. We can see here that we are passing the advanced courses and here we are passing the beginner courses, but besides that small difference, everything else is the same. Now this presents a good opportunity for refactoring our component and reusing the presentation logic for a list of cards. This new component that we are about to create, which is going to be the course card list component, is going to be a purely presentational component, meaning that its only responsibility is to display on the screen some data that we provide as input. The component will not contain any other type of logic. Let's see what this type of presentational component looks like. We're going to head over here to the terminal and we're going to use the Angular CLI in order to generate a new component. We are going to call it courses card list. So this component is going to display not only one course card, but a list of course cards. Let's generate the component. And once this operation is completed, we are going to see here in our project folder a new folder called courses card list, and inside it we have the skeleton of our component. Let's then start by defining the public API of our component. So we are going to be receiving here as an input for our component a list of courses. Let's then define here a courses member variable. This variable is going to be of type array, and we're going to annotate it with the Angular input decorator, meaning that this is an input property of the component. Now let's take the presentation logic from the home component and refactor it into the courses card list component. Let's take, for example, here the list of advanced courses, which corresponds to this particular iteration of a material card. We are going to remove this here from the advanced tab, and we are going to take all of this HTML and we are going to move it here inside the template of the courses card list component. Now we still have here the advanced courses. Instead of looping through this list of courses provided by an observable, we are going to be looping through the courses input property that we have defined here. And let's even give it here a default value, which is going to be the empty array. Let's go back here to our component and see that indeed all of the logic here is working correctly. The routing to a new course will still work. The only thing that we need to move now inside the course card list component is the edit course logic. This is the logic linked to the edit course button. Let's then switch here to the home component and we are going to have a look here at the edit course method. We are going to extract this logic. We are going to take it out of the home component and therefore making it simpler. And we are going to move back here to the course card list component and we're going to apply the edit course logic here. As we can see, in order for this logic to work, we need here the Angular material dialog service. Let's then switch back here to the home component and let's remove it here from the constructor as it will no longer be necessary in this component. So again, we are making the home component even simpler. Going back here to the course card list component, let's apply here the Angular material dialog service in our constructor. And with this, we have completed the implementation of the course card list component. So we can see why this is called a presentational component. The only responsibility of the component is to display some data that we pass it as an input. So the component does not know where the data exactly comes from. The component simply knows that it needs to display the data in this format using this HTML. The input courses that this component is receiving could be anything from a list of beginner courses and advanced courses. It could be a list of courses under promotion that would be displayed in a completely different screen in our application. Anywhere in the application where we need to display a list of courses, we can reuse this component. Let's then see how can we use the courses card list component in order to simplify the template of the home component. Let's start here with the advanced courses. We are going to apply here the courses card list component. This component is going to take as input a single property, which is going to be a list of courses. We are going to take the advanced courses observable and we're going to apply it the async pipe. This is going to send to the course cards list component the values emitted by the advanced courses observable, which are lists of courses as expected by the component. We can now do something very similar here to the beginner courses. Let's delete all this repeated logic and let's apply here another instance of the courses card list presentational component and let's pass it instead the values emitted by the beginner courses observable. If we now try here the new version of our home component, we are going to see that we get here a couple of CSS issues, and that's because we forgot to take the CSS here from the home component that corresponds to the course card and move it into the courses card list component. Let's then take this CSS here, which actually belongs to the courses card list component, and let's pass it to its own separate CSS file. So now when the application reloads, we're going to see that everything is correctly displayed as expected. And we have here the two sets of course cards. But this time around, we have all this logic isolated here in a presentational component where it's easy to reuse in other parts of the application. We can see why this component is called a presentational component. It's because it only encapsulates presentation logic and very little else. On the other hand, here our home component, we can see that now it has very little presentation logic. Actually, the main responsibility of the home component is to access the service layer, extract data from it, and pass it to the courses card list presentational component. So let's see the difference in roles between the two components. The home component knows about the service layer, knows where the data comes from, and it knows how to prepare the derived observables that the view layer needs in order to obtain the necessary data. However, the home component has very little information besides the material tab group of how the data should be displayed. The presentation of the data is delegated to this more pure presentational component, which is the courses card list. The courses card list component, on the other hand, does not know a lot about the service layer of the application. We don't see here the courses service being injected in the constructor, for example. Instead, the presentational component receives all its data via inputs. I think that this way of organizing our components can be something very useful to keep in mind while we are building our application, but I also think that this distinction between smart and presentational components can be taken a little bit too far. So it would be a mistake while you are building your application to try to make every single component that you write either purely presentational or purely a smart component. Sometimes the right approach is to mix both techniques into a single component. Like all design patterns, smart and presentational components are just high-level recipes. They are not strict best practices that need to be applied at all costs. So in summary, whenever you are building your application, try to think about the roles of the different components, who is responsible for interacting with the service layer, who is responsible mostly for presentation. If you see an opportunity to extract presentational logic into a pure presentational component, like we did here with the courses card list component, then go ahead and do so, but don't take this technique and this distinction between presentational and smart components too far. Let's now continue the refactoring of our application into reactive style. Right now we still have a purely stateless application, and what we're going to do next is we are going to take care of the functionality of editing a course. Hello everyone and welcome back. In this new lesson we're going to continue the refactoring of our application into reactive style, and this time we're going to talk about data modification operations. At this point in the course, our application will still remain fully stateless. No state management is being done for the moment. Later on, we're going to see how to add state management techniques in order to improve the user experience. Right now, let's take a look at what a data modification operation will look like without any state management involved. So we have here a list of courses, and we also have here an edit button that will open a new component, which is going to be the edit course dialog that allows us to change the data of a given component. Let's have a look at what this component looks like. Using Command Shift O, I'm going to look for the course dialog component. And here we have it on the screen. So as we can see here on the template, this corresponds to a material dialog with a form field with a few different fields. We have here the course description, the course category, which is a drop-down with multiple options. And we also have here a date, and we have here a description field. At the bottom here we have two buttons. We have the close button and we have the save button. Let's have a look at the implementation of this logic here. So as we can see, the part where we are saving the data in our backend is not yet implemented. That's what we're going to take care of in these next few lessons. And we can also see the rest of the component here on the screen. If we have a look at it, we can see that we are defining here a form group with the multiple form fields that we see here on the screen. And we can also see that we are receiving here via the constructor the course that is getting edited. So that is why we managed to display here, for example, the title of the course and the current values of each property of the course. This data is being passed on to the course dialog via the course card list component. If we open it here, we are going to see that whenever the user clicks here on the edit button, which corresponds to this button here, whenever this button gets clicked, this logic here, edit course, is going to get triggered. And here, using the material dialog service, we have opened a dialog containing the course dialog component. We can see that the course is being passed as an input via the data property, and then the course data is available in our course dialog component via this injectable here. Now let's take care of saving the course data changes to the backend whenever we click here on the save button. So in order to save the data to the backend, we're going to be using again the courses service. So let's go ahead and inject it here. The courses service is going to contain a new method that is going to be called save course. And this method is going to take in a couple of arguments. So the first argument is going to be the course identifier that uniquely identifies the course that we want to modify. The second argument is going to be the changes that we want to apply to the course. We're going to be defining this changes object as being a partial course. This way, if we only want to change one property or multiple properties of the course, we can pass those changes here using the changes property without having to provide a complete course instance. This way, we will still have here type safety in our function. Now the return type of this function is going to be, as usual, an observable, but this is going to be an observable of type any. So the response that we are returning here does not have any predefined type. So the observable is going to emit one value and it will complete if the request is successful, and it's going to error out if the HTTP request to save the course data errors out. Let's now implement the body of the save course method. So we are going to be using again the Angular HTTP client, and this time around, in order to perform a data modification operation, we're going to be doing an HTTP put call. We're going to be accessing the following URL. We're going to access /API /courses, and here we're going to access a particular course by adding the course ID to our HTTP path. Next, as the body of our HTTP put call, we are going to pass in our course changes. Just like the case of the load all courses observable, also here we want to avoid that the returned observable triggers accidentally multiple HTTP put calls if it gets subscribed to multiple times. So we are going to use here the RxJs pipe syntax, and we are going to again apply here the share replay operator. And with this we have completed the implementation of the save course method, which is now ready to use. Let's switch here to the course dialog and let's call this new method. We're going to access courses service, we're going to call save course. We're going to pass in here the identifier of the course that we want to modify. And the second argument is going to be the changes that we want to do to the course object. In this case, let's pass in here the changes constant that we have defined here, which corresponds to the current value of the form containing all the latest values for every property. Let's pass in here changes, and let's now take the returned observable and let's subscribe to it. Let's remember, if we don't subscribe to this observable, nothing will happen and the HTTP put call will not get triggered. Whenever we get back here a value emitted, we are going to go ahead and we are going to close the dialog that we see here on the screen. Let's access here the material dialog reference instance that gives us a reference to the dialog that just got opened. We got it here injected via the constructor, and here we are going to be calling the close method. In order to distinguish this call to close here from the call that we are doing here whenever we click on the close button, we are going to take the value emitted by this observable and we are going to pass it here to the close call. The presence of this value is going to allow us to distinguish between the case where we have closed the dialog without modifying the course and the case where we close the material dialog after a successful save. Going back here to the course card list component where the dialog is getting opened, we are going to see that here, whenever we open the dialog, we get back a dialog reference. Using the dialog reference, we are going to be able to obtain here an after closed observable. This observable is going to emit values whenever the dialog gets closed. So let's go ahead and subscribe to it in order to get notified whenever the dialog gets closed. Now here we want to take into consideration only the cases when the dialog was closed after a successful save. So whenever a successful save occurred, we want this presentational component to be emitting a new output event that will inform the rest of the application that the course data has changed. Let's then go ahead and define here a new component output. We're going to call it courses changed, and we're going to make this a new Angular event emitter. Let's annotate this property with the output decorator. Now here in the subscription to the after closed observable, we are going to be filtering out only the cases that correspond to successful saves. So as we have seen, this dialog is going to emit a value to this observable only in the case of a successful save. Let's then take into consideration only the cases where a value was emitted when the dialog was closed. So here we will be on the presence of successful course saves. Now, whenever a course was successfully saved, we want to trigger this event and inform the rest of the application that the course data has been modified. For that, we're going to be using the RxJs tap operator. So the tap operator is used for producing side effects. If we want to do something like, for example, to write in local storage or to do any other side effect outside of the observable chain, for that we should use the tap operator. Here, as a side effect, we are going to call the courses changed output event emitter, and we're going to emit a new event. Let's now go back to the home component and see how this new event is going to get used. So whenever we perform a successful save, this component, the home component, needs to somehow update the data that we see here on the screen. So for example, if using the edit course dialog, we change the title here of the course, whenever we click here on save, that change should be reflected here on the screen. Now, because this version of our application is still fully stateless, the only way to do that is to reload our list of courses from the backend in order to get back the latest version of each course. This means that whenever the courses changed output event gets emitted, we are going to need to reload all our courses. The same thing is going to need to happen if some of the courses of the advanced courses list gets triggered. So let's go ahead and detect also this event. So now, how do we reload all the courses from our application? Going back to our home component, we are going to see that we need to again create a new HTTP observable using load all courses, and we need to pass it again to our template so that the async pipe can subscribe to the new observable, so that a new HTTP request gets triggered, and so that the new data coming from the server gets displayed on the screen. So the way that we're going to do that is to refactor this logic here from ng on init into a new method called reload courses. To this method, we are going to paste this logic that we have defined here on ng on init, and now on ng on init we are going to simply call reload courses. Now it's important that we never call ng on init directly from anywhere in our component and also from the template itself. ng on init is meant to be called by the Angular framework only and not by application code. Now that we have here a method that allows us to reload all the courses, we can now reuse it here from the template. Let's call it here whenever courses changed gets emitted here on the beginners courses list, and let's do the same here for the advanced courses list. Let's now try out this new version of our application. We're going to switch here to a larger window so that we can see the HTTP requests. Let's click here on edit course and let's change here the title of the course. Let's say that it's the Reactive Angular course with RxJs, just to make it a little bit different. Let's also change the category of the course from beginner to advanced, and let's click on save and keep an eye here on the network tab. So we have clicked here on save. We have done here a request to the backend, a put call containing here the new data that we have defined in our dialog. We can see here the new title, Reactive Angular course with RxJs. You can see that the dialog has closed, and we can see here a new HTTP GET request that got the new data from the backend. Now we can see that the Reactive Angular course has been removed here from the Beginners tab and it has been moved here to the Advanced tab. We can see that this took a couple of seconds because our call to our HTTP backend is not immediate. There is a certain delay in our HTTP service that made our application seem not very responsive for a couple of seconds. Let's quickly see this again in action. I'm going to edit the course again. I'm going to remove the different title of the course and I'm going to switch the course back to the beginner category. Let's click on save and keep an eye here on the network log. So as you can see, the save is still ongoing, and when the save is completed, we got here the new data via another HTTP GET request, and the Reactive Angular course is now back to the Beginners tab as expected. And with this, we have finished the stateless implementation of our data modification logic. Let's now continue the implementation of our application in reactive style. As we have seen, whenever the save data operation is ongoing, there is a slight delay. We would like to be able to show the user a loading indicator so that the user knows that the save operation is still ongoing. So before adding any state management capabilities to our application, let's first implement our loading indicator logic in reactive style. Hello everyone and welcome back. In this lesson we are going to start our reactive Angular journey. You are probably already somewhat familiar with the Angular framework and you are wondering what is the best way of building Angular applications in a reactive way using RxJs properly. The first thing that you are probably asking yourself is, what does it mean to build an application in reactive style? Well, the best way to understand that is to first inspect an application written in a traditional imperative style. We're going to do that in this lesson. Later on, we're going to take a part of our application written in an imperative style and we're going to refactor it into reactive style. We're going to compare the two solutions and analyze the advantages and inconveniences of each approach. Let's then start by going over a small application that is currently written in traditional imperative style. What we see here on the screen corresponds to the home component that we see here under the home folder. We can confirm that by going here to our application root component and seeing that our application is made of a side menu that we can trigger by clicking here on the hamburger icon. And as we can see, we can access here a series of screens. Now, a lot of these screens are in draft state and we are going to be using them later on in the course. The screen that we are focusing on this initial section is the courses screen that we see here. This contains here a list of material course cards. We can see that besides the menu, we also have here a router outlet in our Angular application. If we now open the application routing configuration and we can navigate to that file using Command-Shift-O, we're going to type in here routing and we're going to open the routing module. We can see here that to the root path of the application, we have mapped the home component. Let's have a look at it. The home component corresponds to what we see here on the screen, and it's a very simple Angular component. Let's have a look at its HTML before going over here the TypeScript part. So as we can see, we have here the title, all courses, and we have here a tab group containing two lists of cards. We are looping here through beginner courses, and here on our second tab, we are looping through advanced courses. Now let's go over the TypeScript part of this component. So as you can see, in this home component, we are defining here two mutable state variables. We can see that we have here the beginner courses, which is an array of courses, and we also have the advanced courses of the same type. If we have a look at the course type, this is a plain TypeScript interface where we are defining here a course ID, a description, a long description, and a few other properties. We also have here a sort courses by sequence number function that we're going to be using in our application in order to sort a list of courses using the sequential number field. Now going back to the home component, if you remember, we mentioned that this component is written in imperative style. So what does that mean exactly? As we can see here in ng-onInit, which is triggered whenever the component is initialized and it gets triggered only once, we are using here the Angular HTTP client in order to call our backend, and we are hitting the /API/courses URL. Now, a small side note about HTTP requests in our local development environment. This HTTP request, even though it's hitting /API/courses, is actually targeting our REST server that we are running in our second terminal. So I'm going to open here the endpoint that is getting hit. We are hitting with this HTTP request the endpoint under localhost 9000 /API/courses. And how is this working? Well, this request here would normally hit localhost 4200 /API/courses. But our Angular CLI development server is running in proxy mode and is proxying all the requests starting with /API to port 9000. You can find the configuration for these proxy settings here under the file proxy.json. So as you can see, the Angular CLI is proxying everything starting with /API to localhost 9000. This is a very useful setting in order to run our Angular frontend using the Angular CLI development server locally, and this will allow us to easily redirect HTTP requests to a separate server also running in our machine. This HTTP backend could be written in a completely different technology than Angular, for example in Java, C# or Python. In our case, we are running a small node process that is serving this data here. Now, this data is reaching the home component via this call to subscribe. So here we are using the Angular HTTP client, which is an observable based client. So the call to get is returning us here an observable. An observable, like the name suggests, is going to allow us to observe its behavior over time by subscribing to the observable. The observable might potentially emit multiple values over time. The observable might eventually not even emit any value at all. During its life cycle, we can receive the events emitted by the observable here by this callback that we are passing to the subscribe call. The observable might potentially end its life cycle, although that is not mandatory. There are two alternative ways of ending the life cycle of an observable. Either the observable is going to error out or the observable is going to complete. Either one of those two things happen or none at all. In this case, the HTTP observable returned here by this get call is going to emit one value and one value only whenever the reply from the backend arrives here at our frontend. So this callback here, this function, is going to get called whenever we get the HTTP reply back from the server containing this payload here with a series of courses. Now, when we receive here this response, the first thing that we're going to do is to extract the payload property, and we are going to sort the courses here using this function. So we are going to sort them by the sequential number field. So going back here to our REST payload, we can see that we are accessing this property here, payload, and we are taking this list here, this array that we have here with a series of courses, and we are sorting this array here by this field, the sequential number field. By the way, if you are looking for a Chrome extension in order to properly format JSON, like I'm showing here, you can use the same extension as I'm using. This is the JSON formatter extension that we can find here on the Chrome Web Store. Going back here to our program, let's see now what we do with the courses that we got from the backend. So we are going to loop through the courses and we are going to filter the courses based on category. We are going to create here two arrays, the beginner courses and the advanced courses. These two variables are then being passed here to the view. We are looping through them using ng-for, and we are displaying here the two lists of courses in our tab group. So this small program that we have just analyzed is a good example of how using A service such as the HTTP client, which is an observable-based service, does not mean that our program is automatically written in reactive style. In fact, we can see that we have written our program just like we would have written it if we were using plain JavaScript callbacks or promises. In the next lesson, we're going to then take this component and we're going to refactor it into reactive style, and we're going to talk about the benefits of that new approach.